There are three types of beta decay. We have beta minus decay, which involves electron emission. We have beta plus decay, which involves positron emission. And we have three, electron capture, electron captured by a proton. When you see the word emission, I want you to think of the opposite to absorption. Absorption is when something is gained, and emission describes a loss. Now, each of these processes affects the nucleus differently, but in all their cases, the mass number always stays the same. So mass number is the same, but the atomic number differs. So let's go ahead and look at the first one. Beta minus decay. Look at how this is minus sign. I actually like to think about how the fact that it's an opposite. You'll see why I said that. So in beta decay, a neutron in the nucleus converts into a proton. This transformation happens when a neutron decays into a proton, and as a result, the atomic number increases by 1. Since a neutron turns into a proton, there is an additional proton now, and when that happens, the atomic number will go up 1. When the atomic number goes up 1, that means we're changing to a different element. So let's say our starting nucleus is iron 59. 59 is our mass number, by the way. There's 26 protons, which signifies our atomic number. 59 minus 26 is 33. And that's our neutron. We have 33 neutrons. However, one of them decided to be a proton. We've added one more proton. Now we have an additional proton, and that means our atomic number goes up. It becomes 27. Now we go from iron to cobalt because cobalt has 27 protons. And we see here that yes, the neutrons is 37, but the number of the mass number will still remain the same. Next, we have beta plus decay. The beta plus decay is when a proton converts into a neutron. So a proton, in this case, becomes a neutron. When we lost that proton, that means the atomic number would decrease by 1. Why is that? Because of the fact that we've lost a specific proton. That proton decided, I don't want to be a proton anymore, now I want to be a nucleus, so we've lost it. The mass number remains unchanged. So let's go ahead and look at an example. So nickel 57. 57 is the mass number. And then we have here protons, which signifies the atomic number, Z. To get the number of neutrons, we subtract 57 minus 28. That is 29. Those are 29 neutrons. So now the atom has 27 protons because of the fact that a proton decided to be a neutron. We subtracted 1, it's 27. And 27 means that having that as a proton would mean that the atomic number is different. When the atomic number is different, the element is different as well. So we go from nickel to cobalt, and the mass number will stay the same. Next is an electron capture. In an electron capture, a proton in the nucleus captures an electron from the electron cloud, specifically from the innermost energy level called decay shell. Why specifically that? It's because that part of that shell is the closest one to the proton. So it's easiest for the proton to catch that. The electron combines with the proton to form a neutron, and no particle is ejected from the nucleus. As a result, the atomic number will decrease by 1 since the electron combined with that proton, forming a neutron. So now that we've lost the proton, we once again would have to decrease the atomic number by 1. So once again, let's go ahead and look at an example. In this case, we have nickel with 28 protons. So the atomic number is 28. This is our mass number. 31 is our neutron. And when an electron capture occurs, we would have to subtract the atomic number to 1. It would go down to 27, which leads to cobalt, a new element, and the mass number remains the same. So these are three important things to remember. When a beta decay or electron capture occurs, the atomic number of the nucleus changes. And since the atomic number determines the element's identity, the element will change to a different element. Every time you change the atomic number, you change the element. In beta minus decay, it's actually minus, right? However, I like to think about the fact that it's a plus. A plus will be the effect. In a beta minus decay, we plus 1 to our atomic number. So atomic number increases by 1. The element changes into the next element on the periodic table. Beta plus decay, however, is actually having a plus sign, but it's subtraction. So in beta plus decay and electron capture, the atomic number decreases by 1, meaning that the element changes into the element just before it in the periodic table. And right below here, we have a quick summary of what we discussed.